Something pretty wild is happening in military technology, and it's unfolding right now, in front of our eyes. We're not talking about old school missiles with predictable flight paths anymore. Nope. We are entering a new era with weapons that can literally think, dodge, and overwhelm defenses like never before. So let's get into it and break down what this new arms race really looks like. All right, so here's what we're going to cover. First, we'll look at the arrival of this so-called dancing missile and how it fits into a much bigger strategy. Then, we'll dive into the massive challenge this poses for interceptors and what's next in defense tech. We're talking lasers and AI. And finally, we'll explore why this specific conflict has become a live testing ground for the future of war. So let's start with the weapon that's really changing the game. It's been in development for years, but it has just made its combat debut. And honestly, it's forcing military planners all over the world to face a very, very difficult new reality.
And this really is the core of the problem, isn't it? How on earth do you stop a missile that can dance? It sounds a little strange, I know, but it's the perfect way to describe a weapon that just doesn't follow the old rules.
Think about it like this. A normal ballistic missile is like a perfectly thrown football. It flies in a high, predictable arc. You can track it, you can calculate where it's going, and you can shoot it down. But these new missiles, they're like a knuckleball in baseball. They wobble, they dip, they move erratically. It's almost impossible to know where it's going until it's way too late. The weapon at the heart of all this is Iran's Sejjil missile. Now, it has two huge advantages. First, it uses solid fuel. That's a big deal because it means you can launch it incredibly fast with almost no warning. And second, of course, is that unique ability to maneuver in midair. That's the dancing that makes it so incredibly tough to stop. And what's really fascinating is that this new threat, well, it's not new at all. Development on the Sejjil started way back in the late 90s. We saw tests over a decade ago. But seeing it used in actual combat today, that's a huge escalation. It's the moment a theoretical weapon becomes a very real threat on the battlefield. But here's the thing you gotta understand. The Sejjil missile is just one piece of the puzzle. It's a critical part of a much larger, way more complex strategy. The goal isn't just to hit a target, it's to completely and totally overwhelm the enemy's defenses. This isn't about finding one perfect weapon. The whole idea is to throw everything at your opponent at once. You've got these advanced dancing missiles like the Sejjil and the Fatah. But at the same time, you're launching swarms of cheaper, one-way attack drones. And then you mix in missiles with super heavy warheads, or warheads that split apart, or even cluster munitions, just to create maximum chaos. And just get this number in your head for a second. 80. A single cluster missile can break apart and release 80 smaller bomblets over a huge area. Now, just imagine trying to defend against that. You're not stopping one target anymore, you're trying to stop 80 all at once. It is an absolute nightmare for any air defense system. So it all comes down to this one key idea, saturation. It's an economic game, really. You launch wave after wave of cheap drones and simple missiles to force the defender to fire their multi-million-dollar interceptors. You do this enough, and eventually they just run out of bullets. The whole goal is to exhaust them. So that's the threat. What about the response? Well, facing this kind of attack, the current answer is a layered shield of what we call kinetic interceptors. And that's basically a fancy way of saying you're trying to hit a bullet with another, even faster bullet. Okay, so here's how it's supposed to work. It's a three-step process. Step 1 starts in space. Special satellites see the heat from a missile launch and send out an alert. Step 2 is the high-altitude intercept. Systems like Israel's Arrow 3 try to take out the missile while it's still way up in space. And if that fails, you have Step 3, the last line of defense, where systems like the Patriot try to get it as it's coming back down through the atmosphere. And these are the heavy hitters in that defense shield right now. You've got the U.S. Navy's SM-6, which is specifically built to go after fast, maneuvering targets. Then there's Israel's Arrow 3 for that high-altitude shot. And finally, the good old Patriot system, which serves as that last-ditch, final line of defense. But here's the problem. Even with these amazing high-tech systems, the sheer number of incoming threats in a saturation attack might just be too much to handle. And that's why the future of defense isn't just about building faster missiles. It's about harnessing the speed of light and the power of AI. This might sound like something out of science fiction, but it's very real. It's called directed energy. Instead of firing a projectile, you're shooting a concentrated beam of energy, like a super powerful laser, to zap a target.
And its biggest advantage is pretty simple. You can't outrun the speed of light.
And this is why it's a potential revolution. A single interceptor missile can cost millions of dollars, and you can only carry so many of them on a ship or a launcher. A laser shot, it basically costs the price of electricity, and as long as you've got power, you have an unlimited magazine. This could completely flip the economics of warfare back in favor of the defender. But the hardware is only half the story. The other game changer is artificial intelligence. When you're facing a swarm attack, there's no way a human operator can track everything at once, but an AI can. It can identify the most urgent threats in a split second and slash the time it takes to go from detection to destruction, what they call the kill chain. The software is becoming just as critical as the hardware.
So let's just pull back for a moment. What does all of this really mean? Well, it's so important to understand that this is way more than just a regional conflict. We are watching a live preview of what the future of war is going to look like, and that has implications for everyone.
Yeah, this quote from the source material just says it all perfectly. This conflict has become a live laboratory. The weapons, the tactics, the defenses being used by all sides, they're providing real-world data that will shape military doctrine for decades. And you can see it happening across the board. The US is rolling out its new precision strike missile. Israel is putting its Black Sparrow missile into action and hitting new milestones with its F-35s. And of course, Iran is using its dancing missiles in a real fight for the very first time. It's a massive stress test for everyone's next-gen tech. Which leaves us with one final and honestly kind of sobering thought. We're seeing weapons that travel at hypersonic speeds being guided by AI that thinks faster than any human possibly can. As these two technologies continue to merge, you just have to ask the question, are we heading for a future where the next big war isn't started by a person, but by a single flawed line of code in an algorithm?